Hello, it's Mrs. Grazafi. We are on 2.07 Pre Calc Notes today. Time is flying. So today we're going to be talking about rational functions and graphing those rational functions along with their asymptotes, and we'll also have an introduction into holes in your graph, which you've probably seen before, but we haven't really talked about too much at this point. So we'll start talking about our rational functions. And a rational function can be written in the form of f of x equals n of x over d of x. So I'm calling n of x your numerator, d of x your denominator, n for numerator, d for denominator, where n of x and d of x are both polynomials. And obviously, hopefully, you realize that d of x cannot equal 0 because it's in the denominator. So we'll just make that note right there. All right, number 1. So I want you to find, to do a sketch actually. Sketch the graph of f of x equals 1 over x. And then we're going to answer a couple questions about it as well, about its end behavior. So what's happening at the beginning and the end of the graph, and also what's around the excluded x values. So first, we hopefully know our parent function already, but I want you to think about what points are on this graph. If you want to use your calculator, you can type in y equals 1 over x, and we could type in 1/2 would go to 2, at 1 would be 1, at 2 would be 1/2. You'd have something like this. And then over here, same thing, 1/2 at -2, -1, -1, and 2, 1/2. So you have this hyperbola with two curves in quadrants 1 and 3. So we realize here that we cannot have a 0 in the denominator. So this is not defined at x equals 0. So here is x equals 0. Same with our y-axis. So that's why you have an asymptote there, is because it's not defined by that. Sorry, I don't know if you can hear Suki. She needs to go out. Okay, sorry. So not defined at x equals 0. Think about, can you define it at y equals 0? Can y ever equal 0? So if f of x is y and you have y equals 1 over x, is there anything that you could sub into x that would make y a 0? Well, if I put an x as 1, that's 1 over 1 is 1. I can't put x as 0. I can't change the numerator to a 0 because if I did 0 divided by a number, that would give me 0. If I make it into a fraction, it won't be 0. If I make x into a fraction, it won't be 0. And as x gets bigger, my y is just getting smaller and smaller. So there's no possible way to get this 1 over x to equal 0. So it will never equal 0 for y equals 0, which is also your x-axis. So again, you see you have another asymptote there that it's never going to equal 0. Also take a note here that this is not a continuous graph. And what that means is you can't take your pencil and trace the entire graph without lifting up your pencil. You'd have to lift it up at the end of this curve to hop onto the other one. So a couple things I want you to take note of with your end behavior. So what happens to f of x as x approaches 0? And I'm going to put this little negative symbol, and that means from the left, so from the negative side. So as x approaches 0 from the left, so x is getting to 0, so we're coming towards that red line. So hop on your graph on the pink, or purple rather, or magenta. Hop on and follow your graph towards the red line. As you get towards the red line, it's going down, down, down. So as x approaches 0 from the left, your f of x approaches negative infinity. So it's decreasing. All right. As x approaches 0 from the right, what happens to your y value? So as we hop on our graph from the right side, what's happening? So we're tracing it here, and it's going up and up and up. So f of x is approaching infinity, so it's increasing. And then what happens to f of x, or your y values, as x approaches infinity? So as x gets bigger and bigger, so if we go along our green axis right here and we go towards the right, what's happening to the y value as x gets bigger and bigger? Well, this pink magenta graph is getting closer and closer to that x-axis. So that tells us that f of x is getting closer and closer to 0. And lastly, as x approaches negative infinity, what happens to f of x? So from the negative, on the green axis, as you go to negative infinity, so to the left, the magenta graph is also approaching 0. Okay, so just talking about some end behavior there. Now I want to talk about some asymptotes, rules based off of what we just did. So the asymptote rules we're talking about would be for your polynomial f of x, your rational function, with n of x over d of x. Okay, where we're assuming here that they don't have any common factors. And that will be important when we talk about our wholes later on. So first, let's talk about the vertical asymptotes that you guys are most familiar with. So vertical asymptotes will exist when you set the denominator equal to 0. So whatever makes that denominator 0, whatever makes that fraction undefined, that's where you're going to have a vertical asymptote, whatever number makes that undefined. So if we go back to this example, if we have, our denominator was x, so to make x 0, you just said x equal to 0. So we have an asymptote at x equals 0, which is the y-axis. So that's your vertical asymptote. Whoops. Okay, then we also have horizontal asymptotes, and then there's also vertical slant asymptotes that we may not get to talk about this year, but they do exist with these rational graphs as well. So for horizontal, there's a few different rules you need to remember. They actually come up again, these same types of rules, almost exactly the same idea behind all of them when we talk about limits. So they are really important to remember. So horizontal asymptotes, you're going to figure those out, you're going to compare the degree of the numerator and the degree of the denominator. So there's 3 different scenarios that we could have. If your degree of your numerator is less than the degree of the denominator, so I'm just using n of x, but I'm talking about the degree. So degree meaning the highest exponent. Let's write that in, highest exponent is the degree. So the highest exponent in the numerator versus the highest exponent in the denominator. So here, if the highest exponent in the numerator is less than the highest exponent in the denominator, meaning the denominator exponent is bigger than its y equals 0, your x-axis would be your asymptote. I always remember this is if you're bigger on the bottom, think about wrapping your belt around. So bigger bottom, wrap your belt around to make your circle. Okay, for example, this would be something like x to the second plus 1 over x to the third. So the highest exponent in the bottom is a 3, so that's bigger than the exponent on the top here. For b, we're going to say that the exponent is the same. The highest exponent is the same in both the numerator and the denominator. In that case, y is equal to a over b. You take the coefficients. So that's if your function is equal to a times x to the n over a times x to the m, let's say, b rather. So then you would just take the coefficients a over b. For example, if we took f of x equals 5x to the third minus 1 over 2x to the third. Our highest exponent in the top is a 5, highest in the bottom is a 2, so your asymptote would be at y equals 5 over 2. You don't care about anything that's being added or subtracted, you're just taking those coefficients. And then lastly, if the numerator is bigger than the denominator, there is no horizontal asymptote. For example, if you had f of x equals 5x to the third minus 1 over x squared. Or think about, most of the graphs that you've talked about before. Y equals x squared, your parabola. It's x squared over 1, so the exponent in the numerator is bigger. Then you wouldn't have an asymptote for a parabola. All right, so now we're going to take these and we're going to do a few different examples. So I want you to sketch a graph, and at this point we're going to talk more about these next class, and then we'll do more of it without our calculator. But today I just want you to practice figuring out these asymptotes for the first two, and then the third one will also add in finding a hole as well. And the rest you can just get from your calculator. So here's our function. First, we're just going to find our horizontal asymptote. So horizontal is our 3 different rules, right? So we're looking at the highest exponent. So here the highest exponent is a 1 in the numerator, and here it's a 2. So it's bigger in the bottom, wrap it around, that's your belt. So then you'll have y equals 0. It's bigger in the bottom, or more technical terms, bigger in the denominator. Okay, and then that's our horizontal. Now we want to find our vertical. So to find the vertical asymptote, you're always going to take your denominator, whatever it is, so 3x squared plus 1, and set it equal to 0. And now I'm going to solve. So I divide now by 3, take the square root of both sides, x equals plus or minus. I have a negative under the radical, so I need to pull that out. Square root of 1 is 1 over rad 3. So I could stop here just to practice, though. I'll finish. I don't like to leave a radical in the denominator. So plus or minus I rad 3 over 3 is my vertical asymptote. Now, since that is imaginary, there's no real solutions here. So there is no vertical asymptote. There's no real numbers that are going to make that denominator 0, then we won't have a vertical asymptote at all. Okay, so now let's go into our graph and let's start by graphing those asymptotes. So horizontal is y equals 0, which is the same as your x-axis. And then we don't have a vertical asymptote. So go to your calculator and type this into your y equals, to your y1. You can use your alpha y equals would be best here. Otherwise, you have to remember to put your parentheses on. Go to your table. It might help to find a few points because you'll see the graph, but it's pretty small on there. So if you go to your points, you'll see it goes through at 0, 0. So it actually does cross this asymptote here, which will happen. And then you got 1 half and negative 1 half. And then you'll see it kind of curves back towards that asymptote. So going towards f as x approaches negative infinity, so going to the left, then our y value is getting closer and closer to 0. If we go as x approaches positive infinity, our f of x is also getting closer and closer to 0. All right, number 3. F of x equals 2x squared over x squared minus 1. Okay, so first I'm actually going to start with the vertical this time. I like to start with vertical. So vertical, you're just going to take your denominator, whatever it is, the whole thing, and set it equal to 0. It's always what you're going to do for vertical asymptotes, denominator equal to 0. Now we're going to solve. So I have a difference of 2 perfect squares. So x plus 1, x minus 1, or you could have added 1 and taken the square root of both sides. Just don't forget your plus or minus if you do that way. And we get x equals 1 and x equals negative 1. So here we actually have 2 vertical asymptotes, one at x equals 1 and one at x equals negative 1. Now let's see if we have a horizontal asymptote. So that's when we're looking at our highest exponents. Again, you could have to rearrange these so that your highest exponent comes first. For example, this could have been 2x squared over negative 1 plus x squared. And it still would be this, so I would still always rearrange it so your highest exponent comes first, just like this. So now we look at our highest exponent. It's a 2 on the top, a 2 on the bottom. Since they're the same, whenever they're the same, you take the coefficients. So we take the coefficient of the top, which is a 2, and the coefficient of x squared on the bottom, which is a 1. So y equals 2 is your horizontal asymptote. Again, you don't care what's being added or subtracted. This minus 1 doesn't tell us anything. It's just whatever the coefficient of those highest exponents are. So now we're going to graph these. We've got y equals 2. I'm going to count by ones. And then I have one at x equals 1. So that's y equals 2. X equals positive 1. And x equals negative 1. Again, use your calculator to help you graph this at this point. I know I go through the point 0, 0, so I'm going to hug these asymptotes on the sides. And then I also have curves in this top to the left and to the right of that parabola. So you'll see it's kind of each one is using 2 asymptotes at a time. And it's a very rough sketch right here, just so you can get an idea of what's going on and how those asymptotes help you to kind of see what's going on with your graph. Okay, and the last one, actually before we do our last one, I want to talk about what a hole is. So I'm going to go up here a little bit and talk about holes in a graph. So holes occur in a graph f of x if that graph has the same factor in both the numerator and the denominator. Both the numerator and the denominator. So remember, factors are when it's like x plus a number or x minus a number. So for example, if I had f of x equals x plus a times x plus b over in the denominator, I have x plus b times x plus c. See how we have the same factor x plus b in both the numerator and the denominator? That tells us those would cross off, and that's telling us there is a hole there. So a hole occurs at x equals negative b, so at that root. So if you were to set x plus b equal to 0, you would get x equals negative b. So the hole occurs at x equals negative b. All right, so on this one here, number 4, I want you to find the horizontal asymptote, the vertical asymptote, and any holes as well. So this time, the first thing we're going to start, which we couldn't do before because there was nothing that needed to be factored, is we want to factor it. So we're going to start by factoring our numerator and our denominator. So we have f of x equals, we want something that multiplies to negative 2 and adds to 1, so that's positive 2, negative 1. And in the denominator, we want to multiply to negative 6 and add to negative 1. That's going to be negative 3 and positive 2. So now notice we have an x plus 2 in the top and an x plus 2 in the bottom. Those will cancel out. So now we have the reduced form. And I'll mention a lot now and next lesson that from now on, you want to use this reduced form to find the rest of your information out. Okay, so now whatever we crossed off, so we crossed off the x plus 2's, that tells us we have a hole at the root, so x equals negative 2. So at that hole, I want to actually find the y coordinate, so I only know the x at this point. So to do that, you're just going to sub in x equals negative 2. Again, you want to use in the reduced form, meaning this form right here, because if you put it in the original, if you put in negative 2 plus 2, that's going to give you 0 in the top and the bottom, which is going to give you 0 over 0. We want to know what the actual y coordinate would be of that hole. Now, a hole is a point on the graph where it's not, the graph doesn't actually exist. But we can find the coordinates of it. So I'm going to take f of negative 2. So I'll do negative 2 minus 1 over negative 2 minus 3. Again, using that reduced form. Get negative 3 over negative 5. Never leave double negatives. I get 3/5. So the whole is at negative 2 for the x, because that's what I subbed in, comma 3/5. So that's my whole. And then I want to find my asymptotes as well. So now let's find the vertical. So to find vertical, set your denominator equal to 0. Again, use the reduced form. So we're going to set, otherwise you're going to think you have an asymptote at negative 2 and a whole. So you want to set x minus 3 equal to 0. We get x equals 3. And then you want to find your horizontal asymptotes. So we're looking at our highest exponents. And this one, again, used your reduced form, but it wouldn't matter if you used whichever one you used. So x to the first, x to the first. So those are my highest exponents. Their coefficients are both 1. So if the exponents are the same, then you take the coefficients. So this is like if the n of x equals the highest degree in the denominator, then you take the coefficients. So we get y equals 1. So now using our asymptotes and our whole, I want to graph this information. So I've got y equals 1 is right here. I've got x equals 3, 1, 2, 3 is here. And then I have a whole at -2 3/5, and I'm just estimating where that is. And then you can use your calculator. Your calculator won't show those holes, but you can get an idea of where it's going to hug those asymptotes. And then next class, we'll talk more about finding one point on either side of that vertical asymptote, so you know if the curve is going to be up here or down here. But at this point, you can just use your calculator to do that. Make sure you actually typed it in and didn't just copy down what I wrote. So pause it, type it in your calculator to double check that you get the same thing. So again, you'll have a hole here where the graph does not exist, and then it goes infinitely close to that on either side. It just doesn't touch that exact point at -2 3/5. And then the other side doesn't have any restrictions. It's just going to have x is going to have to be greater than 3 and y is greater than 1. All right. We have one more that I would like you to do. F of x equals, do 7x squared plus 3x to the third plus 2 over 5 minus 4x to the third. So first thing I want you to do is rearrange it so that the highest exponent comes first and in descending order. Go ahead, pause, and do that right now. Right, so we have 3x to the third plus 7x squared plus 2 over -4x to the third plus 5. For this one, I want you to find the vertical asymptote, horizontal asymptote, and your domain. So go ahead and pause the video and find those things right now. Okay, so for vertical, you're setting your denominator equal to 0. So we have -4x to the third plus 5 equals 0. And we need to solve that. So I'm going to subtract over the 5. So 5. Divide by -4. And then I get 5 over 4. And now I want to solve for x. So I'm going to take the cube root of both sides. So I get x equals the cube root of 5 over 4 for my vertical asymptote. Then for my horizontal asymptote, I'm looking at my highest exponents now that I've rearranged. So x to the third on the top, x to the third on the bottom. They're the same. N of x equals d of x, which means I take the coefficients, and I always have to write it as an equation because these are lines for the vertical and horizontal asymptote. If you just write a number, you do not get credit for that because it's not a line. So here, very important, you have x equals the cube root of 5/4, and here you have y equals -3/4. And then lastly, our domain. We've already set our denominator equal to 0, so we know where it's going to be undefined. So we can just now say our domain, I'm going to put it in set builder notation, is x, where x is an element of the real numbers, and x cannot equal the cube root of 5 over 4. Even if you just wrote that out in words, x is a real number and x cannot equal the cube root of 5/4. That's the only restriction here. So wherever you have a vertical asymptote, that's going to affect your domain. All right, that's it. If you have any questions, please let me know. Pi out.